Hello, everyone. Thanks for joining. Thanks for being interested in learning about WebdriverIO. I'm happy to share what we want to do today. And it's pretty much a presentation. I want to give you some updates on the project. A lot of things has happened, especially over the last 2 weeks, interestingly, that where a lot of new great changes have happened. And I want to give an update about that, about WebdriverIO in general, how it works. I still feel very convinced that everyone who wants to champion an automation framework needs to understand how it works underneath. And so that's what I'm going to do in the presentation. And then we will look into the hands-on workshop. I hope you all have received the link to the workshop. It is a GitHub URL or GitHub repository on github.com/webdriver/workshop. So if you already work with WebdriverIO, you don't need to listen to me talking about it. You can directly jump into the workshop and get started. About the workshop, we have about a bunch of chapters we will work on. Every chapter is kind of built on top of each other. So it starts with setting up an environment, building a simple automation script, and then we move ourselves up to building a Wdidio test runner, use reporters and services, some performance testing, some PWA testing, some customer reporters and services, as well as CI/CD integration, source integration, page objects, visual regression testing, TypeScript. I'm sure we won't be able to cover everything. So if you don't feel so interested about a certain chapter, you can always jump ahead and go to the next one. But overall, we try to go step by step so everyone can follow along. And if you get stuck within the chapters, so every chapter essentially gives you a small task or a set of small tasks that you can do, give some explanation, and then it asks you to implement something or to integrate something. And if you get stuck along the way, you can ask us, me and Enrique. That's why we're here. You can either unmute yourself and ask here in the stream directly, or you can write us in the Slack channel, whatever you prefer. Me and Enrique will try to help everyone. And yeah, when you get really stuck and you want to just see how it works, there is for every chapter a solution. So you can take a peek at that. But feel free to just first try it yourself. I don't think these chapters are all too difficult. They should be manageable. Cool. With that being said, any questions for the agenda or for our workshop? Anyone missing something, or anyone needs something, or anyone has a question? All right, I think we're good to go. What's the link to the GitHub again? So you go on github.com/webdriverIO/workshop. Oh, thank you, Enrique. Perfect. Sweet. So let's start. The nuts and bolts of WebdriverIO. So I've introduced myself. I'm Christian. Let's start with going into the really root levels of what is browser automation. And we cannot go around of talking about the WebDriver protocol. I'm sure everyone has probably heard about that. I'm sure I think a lot of people in the community and in the ecosystem still don't really fully understand what the difference is between Selenium and WebDriver. It used to be one thing, and now they are completely different things. And so that's why I always like to have like a little explanation about what the WebDriver protocol is. So essentially, if you look into the spec, or if you look into the definition of WebDriver, WebDriver is a remote control interface that enables introspection and control of user agents. So that sentence has a couple of interesting phrases in it. So it's a remote control interface. That means that you can control something that is not on your desktop or not on your local machine. It enables introspection. and control. That means that you can kind of like introspect that user agent and control it. And the user agent itself can be anything from a browser, which it is usually, to a mobile device, or even a smart TV, or there's a TV that is connected to a PlayStation. Those are all user agents, something that has a user interface. The Webdriver protocol itself is defined by the W3C. It's a web standard, and therefore every browser has to comply to it. And you can find the definition of the WebDriver stack on the internet. I think it's w3c.github.io/webdriver. I can send you a link after the workshop if you're interested to look how this kind of specification looks like. And essentially, the WebDriver stack defines a set of endpoints, REST API endpoints, that when being called with specific parameters or payload, it triggers a certain command in the remote user agent. So that can be, creating a session means start up a remote agent, post URL, navigate to some page, forward, refresh, get the title of something, and those are all defined in REST API endpoints. What makes this, let me 1 second get my window closed, sorry about that. Hectic city. So what's, to sum this up, so the WCC's, the Webdriver protocol is the official W3C standard. Again, every browser vendor has to comply to it. That means that if Safari releases a new version, they will make sure that the Safari can be automated with that protocol. It's a predecessor of the JSON wire protocol. That means that in the earlier days, we used to use that protocol, but then we brought it to the WCC, or people brought it to the WCC, and now it's an official web standard. It's not Selenium. It used to be Selenium WebDriver because the whole Selenium project used to own all the browser drivers, and therefore we're responsible for maintaining these drivers. Nowadays, as it has become a web standard, every browser vendor is now responsible for that. So there is a big group of folks that help maintain these drivers and are responsible for maintaining these drivers. And Selenium itself is right now separated, I think, the Selenium grid, the Selenium framework, that means the client to automate a browser for all languages, and the Selenium IDE. I think those are the three products that are kind of like create or wrap the Selenium project. It defines a REST interface. The interesting design decision behind that was that you can automate this. You can use this protocol with every language that is out there, and it kind of like tries to define commands that are possible to automate in every browser to really allow a cross-browser automation. Again, it can be used in all languages because it defines a REST interface. There are also other protocols you might have heard about that can also automate the browser. One really popular one is the Chrome Devtools protocol. The Chrome Devtools protocol was mainly created to help the Chrome debugging interface, or the Chrome Devtools to automate and introspect the website. But it was enhanced to allow automation using a framework called Puppeteer. These days, Chrome Devtools protocol is more used by automation frameworks. It is also used by WebdriverIO and other tools like Puppeteer, Playwright, and I think Cypress as well. And the way this setup looks like is kind of like this. You have your test script on the top left, and this test script sends REST request with like normal HTTP request to a driver. And there's, for every browser, you can download a driver these days. There's a Chrome driver, Gecko driver, IE driver, Edge driver, Safari driver, and all those drivers can automate a particular browser or user agent. The same works for mobile. We have Appium that kind of like builds drivers for a lot of mobile devices. And overall, you can create a set of drivers and Appium instances using a Selenium grid, which is really powerful. Again, we have, there are so many automation frameworks these days. We have Playwright, Puppeteer, Cypress. All these frameworks, they are mainly not using the Webdriver protocol. They're using from Devtools or like their own automation, their own way to automate the browser, which has some limitations, but also some advantages. And again, with the idea of having a translator that can translate a common automation command, like clicking somewhere, into a remote device, allows us to even build automation drivers for smart TVs, like this one, which is an Appium driver that allowed me to automate an HPV application on the TV. So the value proposition of Sauce Apps is kind of like is kind of easy. Instead of you having to maintain all these browsers, platforms, devices, and browser drivers, you use Sauce Apps to have this all under one service. And on top of that, you get the images, the logs, the videos, and capabilities like performance testing on top of it. I'm not sure who of you has already maintained a device farm or a grid, but it can be a lot of work, especially if you have to constantly update the browser and if you have to look into what is going on with certain VMs and things like that. Getting now to WebdriverIO. So there are a bunch of key features that I feel really proud of that Webdriver has them. One is the easy test setup. If you download the CLI client, you just say Wdio config, and it provides you a wizard that helps you to set up your environment. It has a lot of third-party integrations. One that Enrique recently just mentioned is the Sauce service, which, for instance, gives you access to a nice integration to the Sauce Labs platform. It will update your job. It will start Sauce Connect for you. It will give you some job context in your command list. A bunch of nice things that you usually would all have to implement yourself if you use a different framework that has no integration. It has first-class TypeScript support. So with Webdriver version Z, we moved to TypeScript. We transformed the whole code base, and now we have really good support. I think we can still improve some things here and there, but overall, the support for TypeScript has improved a lot. And that helps you to write tests that have stable types, and you don't get confused with what this certain command needs as a parameter and whatnot. We also have now much improved Google Lighthouse integration. I'm not sure if you have heard about Google Lighthouse, but it's a tool developed by the Chrome team that helps you to audit your web application. And right now we have embedded a couple of features like testing for PWA, which we're going to do in the workshop, as well as performance testing. There are a lot of tutorials and learning content. So the Webdriver community is a big community that puts a lot of stuff on YouTube for free. So you have a lot of material to learn from on YouTube, which is a medium that I usually prefer to learn new things. And we have a community that supports you all. So if you have struggle using automating a browser, or if you run into any errors, there's a GitHub support chat that you can join at any time to get some support on your test automation journey. And lastly, something that I feel is very important, WebdriverIO is not owned by Sauce Labs in any way. It is owned by the OpenJS Foundation, alongside with projects like Node.js, Webpack, Express, AMP, and Fastify. So the JavaScript ecosystem is large, and a lot of big projects are part of the OpenJS Foundation. That means that the goal and the future of WebdriverIO is not depending on a company or the economic interest of a company. It is owned by a community, and so if anyone in the WebdriverIO community steps down or stops contributing, there will be always people that will be able to contribute and move the project forward. Getting into a little bit more into depth in WebdriverIO. So there are three different modes that you can use. There are three different modes in WebdriverIO. You can use it bare metal in the so-called standalone mode or with the Wdidio test runner. The bare metal mode is pretty much the protocol abstraction that WebdriverIO has, and there are currently two. With one for Webdriver as well, one for the Chrome DevTools. So Webdriver was able to switch around these bare metal libraries and allows you to automate either with DevTools or with Webdriver or even with both. So the first abstraction, the first layer is the bare metal layer, which is the protocol abstraction. Then we have the standalone mode, which is the WebdriverIO package itself. Oh, wait 1 second. Can you see, what do you all see?
I am seeing just a screen. Yeah, I'm seeing like a browser screen. Oh no, that's
interesting.
You?
Let me check.
I think there's something, my desktop start to share. I think this is my desktop.
Oh, okay. 1 second, I can
yeah,
fix
you
that.
must go back and take it back from me. I don't know how this happened.
Can you confirm?
Yeah.
Oh no, wait, sorry. Oh, can you stop sharing by, yeah, that's the share button.
This one?
Yeah, and it
Yeah.
must be.
Or what should?
That's interesting.
How did this happen? Stop sharing. Ah, now.
There we
I
go.
found it. Okay. Oh.
Perfect, we're back on track. Okay, so my screen is now the biggest again?
Yep.
Perfect. All right, so again, the standalone mode, which consumes these bare metal packages and builds some additional, let's say, sugar on top of them to make it really easy to automate certain things. So it has commands like drag and drop or easier methods to switch windows, things like that. And the outer layer of the project is the test runner, which comes with all the harness and capabilities that you need to build scalable test suits. So again, here's an example of the bare metal mode, the Webdriver package. People who want to use this package usually want to build their own automation framework and own automation library. There's some great examples like Concept.js uses that, or the Spectron package, which is the automation framework to automate Electron apps, uses that as well. And if you use that, you have to know a little bit about the Webdriver protocol to understand what is being returned and how you automate with it. There's no safeguards in there. There's no retries or things like that in there. It's just the bare communication with the protocol. The next step, WebdriverIO, the middle layer, which is already looks a little bit simpler because the, for instance, querying elements is much simpler with one $sign command, and there's lots of logic behind it to make automation just simpler in general. And then with the test runner mode, we get like some the nuance of testing into this whole game. So it provides you integration to popular test frameworks and creates reports for you, allows you to integrate into platforms and so on. If you start with a WebdriverIO framework, you usually start to install the CLI client. The CLI client is your friend and helper to run certain suits, to configure your environment, to install additional plugins. And when you configure WebdriverIO using the CLI client, you start getting a config file. And that config file really contains everything that WebdriverIO needs to run. There's a lot of options that you can control and modify. And I'm always careful to add new options because it can be really confusing at some point. It can define things like where are your specs located, how many instances you want to run in parallel, what are your capabilities, which are your plugins, your reporters and services you want to load. And you can modify these configurations. So every configuration file is just a JavaScript or TypeScript file that you can modify based on certain environment parameters or other things. And you can be really creative in generating your configuration object. Something that I like to, that I would like to say to people who build their frameworks is that, it's always good to have a main WebdriverIO config file that contains all the things that normally never change. And then you have a specific file for your development environment, a specific file for your staging environment, and a specific file for a production environment, so that you can easily switch your environments just by passing a different config file to the CLI client. That will move away from the having one bloated config file towards a lot of nice little separated config files that only define that for what they stand for. Right, this is an example where the config file for a staging platform was defined, where the staging platform is using Sauce Labs to run automation test at scale. And we see that we import the main config file and then generate, inherit from that main config file and just apply the configurations that are important for our environment. In this case, applying the user and the key, as well as defining different capabilities. Webdriver supports mainly three test runner frameworks. It is Mocker, Cucumber, and Jasmine. It, however, kind of also supports Jest in the sense that if you write your automation test with Mocker or Jasmine and use the expect WebdriverIO assertion library, then your test your test will look like Jest test. There's no intent of the team to also provide a Jest framework adoption, because the Jest framework test runner doesn't provide any capabilities that we don't already have in the other three. So it will be likely, there will be likely no Jest test runner. But your test, if you already have Jest as your unit test framework, you can make your test look like Jest test essentially. And something I've been recently working on is an Autonomic Framework adapter. I'm not sure if you have heard, but Sauce Labs has acquired Autonomic, which is an AI platform to run your test on using AI technologies. And it will be essentially work like Cucumber, like the Cucumber framework, without you having to write the step definitions files. So there's a specific set of feature steps that you can use, and Autonomic will take care of making the automation happen in the cloud, which is really fancy. And I hope I can share more about that soon. Again, the set of plugins and extension looks as follows. We have framework adapters, we have reporters, and we have services. And services, to go to services now, are a specific set of code that allows you to hook into specific areas in the testing lifecycle. So you can do certain things on prepare or on complete, before a test or after a test, before a session or after a session, to do various things of, for instance, setting up your database, or I don't know, creating users for your test, or doing certain things after a certain command got a certain result. You can be really free here and can really do interesting things. You can build your own service and share it among your own organization. I've met a lot of customers who have done exactly that. They have nicely a set of various own services that they use to integrate with their own infrastructure, to report information and to do various of things. One example of a service is, for instance, the Devtools Service. The Devtools Service, when you launch the browser, it not only connects through the Webdriver protocol, it also creates an own connection to the browser, in this case Chrome, to allow you to do certain things with the Chrome DevTools protocol. So we use the Wdidio DevTools service to, for instance, provide the whole Lighthouse integration into WebdriverIO. But there are also more features. Just go quickly over them. We have a bunch of interesting selector abstractions. So in Webdriver, you don't need to know what the selector strategy is called like. We have some formats that you can follow, and Webdriver will automatically transform them into the right selector strategy. So if you, for instance, say, I want to query an HR1 that has the text "Welcome to my page," then Webdriver will automatically generate the XPath to make this query successful. We have also React-specific commands to fetch React components by their state and their properties. So that was also a contribution by a community member, and we embedded this into the core of WebdriverIO. And this is really powerful if you work with React applications. And very recently, I think yesterday, we have released a new deep selector in WebdriverIO, which allows you to query elements within the shadow DOM. For that, we used to have a shadow $sign command, but the shadow $sign command only allowed us to go and look into one shadow root. And if we look into this example, we have two shadow roots, one of the downloads toolbar and one of the CR action menu. And with the deep selector, we are now able to look through all the shadow roots and query an element wherever it is located, right? So the prefix of this selector is the three greater S signs, and you just pass in the CSS selector afterwards, and you can find that element within the shadow root, which is really, really nice. And of course, since we have integration into Appium, we have a bunch of nice Appium selectors that help you to simplify creating selectors for mobile. An additional way to abstract logic in your test is by using custom commands. You can create custom commands to abstract any kind of logic and build it right into your test flow. Here, it's always interesting to think about, if I want to register this command to the browser, or does it make sense to create a page object? So if you're already using page object, it sometimes makes sense to create a page object for your REST API to interact with that much easier. If you prefer to attach it directly to the browser, you can do that, like in this example, to delete a user from the database. Another feature of Webdriver is the multi-remote feature. So normally, in most cases, you have a normal test that has a test file and that automates one browser workflow. But with multi-remote, you can always have multiple devices that can interact with each other in one single test. And this is very useful if you think about testing chat application or games where you have multiple users that need to interact with each other in a single test. So a lot of users use that to achieve that kind of automation. I will skip over the page object model because we have this in our workshop. Just to give you a little heads up, this is how a page object model can be defined in WebdriverIO. You have getters and setters and methods using the class capabilities of JavaScript, and you just define a getter to return an element, and then your test can be nicely abstracted away, so that essentially the idea of page object is that you can, essentially redesign your web application as long as your workflow stays the same. you only need to update the page objects and never have to touch your tests again. But yeah, this is how this can look like when using page objects with WebdriverIO. And last but not least, just to announce the recent major release that we had in version 7, where we dropped support for Node.js version, it's supposed to be 10, not 19, and below. We've rewritten the entire code base into TypeScript, updated to Cucumber version 7. We improved the Google Lighthouse integration, added new commands to check PWA, which we're also going to do in the workshop. We have now auto-compiling for TypeScript and Babel. That means you only need to have to install a single npm package, and WebdriverIO can automatically compile your test files or your configuration into TypeScript. There's now a little bit more stricter protocol complaints if we move more forward to the WebDriver protocol and abandon the JSON-wire protocol. We have a test coverage reporting feature in the Devtools service, and we updated our documentation page. We got it a new design, and yeah, I can real quick share the link with you all. Right. So what's the future going to look like for WebdriverIO? You know, that future, we don't have a fixed roadmap in the sense that we say, okay, in this quarter, we're going to build this, in this quarter, we build this, in this quarter, we build that. We have a couple of ideas where we would like to invest time in, and those ideas can always change. And if someone comes up with a nice feature or a nice idea, we would be always happy to include that into the project. So some of the ideas that we have is to build a fiddle web application for WebdriverIO, so everyone can share their test code and help other people to debug their things. We want to provide better debugging capabilities into WebdriverIO, allow something called network snapshotting. That means that WebdriverIO automatically checks the network request that your browser is doing, and with the next test allows you to mock or to verify that these requests have the same payload or a similar payload. And we would like to have an improved frontend framework support. That means that we want to integrate even deeper into frameworks like React, into frameworks like Angular or Vue to help front-end engineers that use these frameworks to just build simpler automation tests. Very recently, I don't know if you have heard, is that the Angular team has announced basically the end of Protector, and so we built now a test and like an Angular CLI integration and have a code mod to help people to move from Protector to WebdriverIO. And even more recently, actually today, someone has released. If someone has used Protector before, someone has now released an expected condition API that is about the same as WebDriver had, where Protector had. So we have this now too, which helps also more. If you have been working with Protector before, it will help you with Webdriver as well. That's about it. Any questions to the presentation, to the project before we dive into the workshop? I guess that's a no. Awesome. All right. So if everyone has a question, just feel free to unmute yourself, raise a question, or file a question in the chat. Me and Enrica are here to help. So let's start with the first chapter of the workshop, which is an easy one because you only have to set up a Chrome driver on your system, which is essentially useful when you test Chrome on your local machine before you write your test, and while you're writing your test, and push it up to your GitHub repository. So when I write my tests, I usually always have a Chrome driver installed. So I can show you that in my IDE. So in this chapter, we want to download Webdriver, and if you follow the steps defined in the chapter, you will be able to open Webdriver from your terminal, ideally. So that means that in your terminal, you can write Webdriver -- version, and it will give you the version of Webdriver. That being said, we note that every Webdriver version is connected or directly connected to your Chrome version. So if your Webdriver version says something like, or if you start a test or an automated test, and the error says something like Webdriver is only able to automate Chrome version 89 or 90, then this means that your Webdriver and Chrome version are different. So always make sure that your Chrome has the same version as Webdriver. And so when I write tests, I usually have my terminal open and start Webdriver using the port and the verbose tag, so I can see what the underlying Chrome DevTools commands look like. So, so once you're there, you have Webdriver set up, and you can run your WebdriverIO script. Maybe I can show you. Let's see if I can open Tmux. Okay. So let me just show you in a real quick example how these different protocols look like when you write WebdriverIO test. So let me just create a test script. Let me go download solution. Let me install WebdriverIO. While this is installing, we can start our Webdriver. And I can start writing my test already. I think this already takes a little bit away from chapter 2. So what I do here is writing a little WebdriverIO script in a self-invoking function. That means I define the function and immediately call it. And in there, I define my browser that uses a wait to call this remote function. So every WebDriver command essentially is asynchronous, because there's always a remote call to a browser driver. And that means that you always have to write your commands asynchronous. WebDriver used to have a synchronous, or still has a synchronous way of running things. But this will likely be deprecated with Node version 16 due to changes in Chromium, which is being used by Node.js. So here we define our capabilities, and we just want to automate a Chrome. And thanks to the TypeScript definition, you should already see some. You should see some description about the properties that Webdriver supports. And if we say browser.ul, SauceCon.com, and that's all I want to do. So my internet takes quite some time. So let's see, to install that npm package. So yeah, so the first chapter will be just about installing Webdriver, creating a directory. It also initiates Git. If you don't have Git, don't worry about it. But it might help you to make a commit after each chapter to be able to go back to a previous chapter or just to switch around your code. But once you have Chrome Driver installed and get a message, something like this, you'll be good to go to move forward and go to chapter 2, which will be about writing an automation script using standalone mode, which I'm just about to do. If my npm installs. And it finally did. Perfect. So I'm going to run this simple script that is really just about initiating a remote session with Chrome. I can make it a little bit bigger. Oh, a little bit too big. Keep it like this. So it just initiates a remote session with Chrome on my local machine because I have not specified any Sauce Labs or any vendor here, and it's just using Chrome as the capabilities and then starting the SauceCon app and turn it down. So if I do that, you will see on the right side where I have Chrome Driver running that Chrome Driver will do things. It's going to translate the Webdriver commands into Chrome DevTools, which is the interface that Chrome understands. So if I run the script, you see that Chrome Driver is launching. And it's opening SauceCon. And it closes the session, as easy as that. And it's always interesting to, at least when I work on tests and something doesn't work, I like to look into in all these events that Chrome Driver is sending to Chrome, and they have some interesting, you see the parameters that Chrome that Chrome is being launched with, and a bunch of other information that Chrome Driver exchange with the browser. So now if I close the Chrome Driver, you might think that WebdriverIO has nothing to communicate anymore and cannot automate Chrome. Well, that has been like this for a while, but with the addition of the DevTools bare metal package, WebdriverIO now automatically detects, hey, there's no driver running, so I just do everything by myself. So it uses Puppeteer under the hood to find a Chrome on your machine, to launch it with Puppeteer, and essentially do the same automation as we have with the WebDriver protocol. So it's doing the same. You see a little bit different output here. You see when you do a command with WebDriver, you have a URL that the request is being sent to. With Puppeteer and DevTools, we don't have that, so we only have a command and a result, and no URL in there. Yeah, I think if I look into the workshop, so just to be, let me run a poll real quick. So has anyone finished chapter 1? I'm not sure if you all see the poll. If you have still any trouble working on chapter 1, please let me know. Otherwise, we continue with the second chapter, which is about writing our first automation script. All right, so for the second chapter, all right, with 10, we have still one working on the first chapter. So I can already explain chapter 2. If you still have issues, feel free to let us know in the chat.
Yeah, let us know in the chat and I can help.
Okay. Does the video still?
And they're mentioning, Christian, something that I saw as well is that your video seemed to be freezing. I think it might have been when you were installing WebdriverIO at the very beginning.
Yeah,
but,
I guess my CPU at some point is melting.
Yeah, that's what you get for having German internet.
It's my CPU, not the internet, but yeah, internet might be also related to that. Okay, so I will make sure that I don't put too much pressure on the CPU. Okay, so the second chapter will be about writing an automation script in standalone mode. When I think you have created your directory, and there should be Webdriver installed. So as I did with in my example, I was running Webdriver on the side using the command Webdriver --port 444 -- verbose. That should get you running. We will automate this. So when we get to a later stage, this will not happening manually anymore because Webdriver would take care of this. But for the start, it's a good exercise, I think, to look into that as well, to do this manually to see what happens under the hood, right? So next is to write this automation script, and we use the To-Do MVC app. You probably have heard about this one. It's an example application that is implemented in all frameworks that exist on the internet, I think. So you don't need to use the Vue one. You can use any one that is available here using React, Vue. There are ones with Polymer, with Ember, whatever you prefer. But the Vue one is the simplest one. And here, what we want to do is we want to write an automation script that enters 3 items into the to-do list. It marks the second item as complete, and then prints out the amount of items left. So essentially, if I do this manually, milk, butter, I don't know why I use that, water. You enter 3 items, you complete the second one, and then we want to get the number right here. Not the 2 items left, we want to only have the 2 in there. And using a standalone automation script, as I have shown in my IDE here, you can just follow the same structure, writing a self-invoking function. So you can use async await and don't need to do any nested thens or promises. So this might be nice this way. And anything else? Let's see. And then we have, just follow the structure as mentioned in the chapter description, and there will be some extra tasks for you that you can tackle if you still have some time. So the first one will be when entering these 3 items in the to-do list, you can do this with 3 commands. But you can also do it with 1 single command. And if you can find out what that 1 single command can look like, you can solve this first extra task. The second command is using the Devtools protocol. So the Devtools bare metal package. You can either say directly instrument WebdriverIO to say use the Devtools package, or you can just shut down Webdriver to use Devtools. And we want to use Puppeteer to mock out the response of the server. And for that, I feel like For that one, we need the REST API. Oh no, there's a different test one. Oh yeah, we need to modify the local storage, which is the database that the application uses to store their items. So if I reload the app, you will see that the items are they're still there. So Vue.js uses local storage to include or store these items for the session. And we can use Puppeteer to modify these items. And the last extra task will be to use the same to-do application, but with a REST API. And our task will be to mock out the REST call that the application is doing. So instead of the difference between the applications is that one application is using the local storage, like the Vue one is using the local storage. The one that I've linked in the workshop is using a REST API backend. And so this extra task, we want to mock that REST API backend to fill out or to insert items from our test rather than using our REST API. Okay, so let me switch back to IDE. Okie dokie, so this looks much better. And my automation code. So first we open the application using the URL command. And then we look into, you can take a look into the one-to-one. Copying this over. So the documentation on the Webdriver page assumes that you are using Webdriver in sync mode. With the standalone package, you don't have access to, you don't have automatically access or it's not configured in a way that you can use sync mode. So we have to continue writing our async weight scripts and commands. And also, since we are not in the test runner environment, we don't have the $sign, the dollar command, or anything exposed to the global environment. So we have to prefix the dollar command with browser dot because originally the dollar command and every command is assigned to the browser. So we found, okay, so we fetch an element and we set the value for it. And what we now need to do is to go into the Vue application and find the inspector, to find the selector for that element. And luckily, this one has a nice class. So we can enter it here. And we say milk and enter. So the space enter means that Webdriver will transform this string into an actually enter event that you can do on the keyboard. So that should be, I will do a little pause in there so I can check if my results are okay. Interesting, okay. So what did not work was the enter thing. And there you have an example that I'm also sometimes not sure how things work But the set value commands, as you can see in the little toolbar here, takes a value and a value string, value array. So that means that instead of just passing in a string, we can also just or space, then this should work properly. Trying that again. And it worked. So the next thing is finding out what this little counter looks like. And this also has a nice class that we can use. Do count span, I think it was. And we just lock it counter.getText. That looks good. We fetch the element and then we get the text of that element. Let's see if that works. It does not. You nicely see that Webdriver is refetching the element. It does this retry mechanism because it couldn't find the selector. So let me dive in a second time to see what I did wrong.
Christian, we can only see the website itself. We're not actually looking at your code right now.
Okay, good point. I have to switch. Thanks for notifying. Okay, so looking into, so it's not a span, it's a strong. It's running this again. Should hopefully not do it. There we go. We have this number 3 here, which is the right thing. So there's one last thing missing, which is checking up the second toolbar, the second item. Going back to the page, and I'm opening Devtools again. And you see, so the way to go around about this is that you just try to fetch all the elements first that you're interested in, or where that like wrap, or try to fetch the element first that you're interested in, containing all the other elements, which is in this case the to-do list. And we're interested in all the LEs in there. And then we can just pick the second LE and do another query on that LE. And for that, we need to just have the toggle as class. Okay. So first we fetch all the elements, like all the to-do elements. So we do this. We define a variable. This time we do use the $$ command, which is the command to fetch multiple elements. So it's to-do list LE.
We're still on your website, Christian.
Oh. Good point. It's a to-do list LE. And so once we have that, we have an array of to-dos. We have an array of elements. And so we just pick our first element, and then we do a query on that for the toggle button. So the next element is our toggle, and for that we use we take the first to do, which is, since array starts with 0, it will be the second to do in the app, and then we use the $ command on that. So this is the so-called command or element chaining. So you can query elements based on another elements. That means that WebDriver will look into all these children of that sub-element. And since we are only interested in the toggle button of the first element, of the second element, we just use that as a scope. And so this one has a button that has the class toggle. And lastly, once we are there, we can just say toggle click. And that should be it. Let's see it. So it's supposed to be return 2 now. And I was right. So we have now 2. That means that we, I think, accomplished the workshop chapter. So marks the second as completed, print down the items amount left. Perfect. So I will go into the first extra challenge because the second one and the third one would be kind of a little bit overkill, and we also have to look at time. But the first one is pretty simple. Going back into the IDE. So as you can see here, the set value commands can take a list of the inputs. So if I would say milk, it would enter milk twice. But if one item of that array is something like enter, or it's something like space, or num8, I think. Let's look into the docs just to find out what is possible. So the set value has here a link to all the supported keyboard actions, and you will direct it into the W3C spec. There's a plan to make this a little bit more simpler. We will allow to import a key object that has all the properties in it. So it will make this part much easier. Yeah, there we go. There was it. Yeah, all these codes that you see here, backquote, backlash, those are all possible keyword events that you can throw. And so we have one enter here, and Webdriver will transform this into this. So you can also directly use this code in your set value string. But this is for some things. I mean, you usually always use the common things like enter, space, shift left, things like that. Nothing like really crazy F keys. So if we now say, okay, we first enter milk, then press enter, then at banana, press enter, and then press cherry and enter, then it should do everything in one command. And if you would ask yourself now, why is this important? You can do the same thing in 2 different ways. Well, this will only do one WebDriver command, and particularly if you run tests on a cloud vendor like Sauce Labs, every command counts. Every command increases your test execution time, and depending on your network capabilities or the network status in general, a command can take up to 100 milliseconds. So if you have a lot of set value calls and you can just chain them like that, it can speed up your tests tremendously. So Let's see. Let's rerun this again. We should get the same output. And also the execution is much faster in the browser itself. So you couldn't see my browser, but essentially before you were seeing milk being entered, then banana being entered, then cherry being entered. And with this approach, you see all items being entered at once, and much faster than before. Cool. Let's go back to the workshop. Just a quick poll on where we all at about chapter 2. So please answer the poll on where we're at, and then we can either move forward or go into something specific. I'm happy to just quickly go over the solution for the other, for the extra tasks, to just show you what this task was supposed to entail. So the first extra task, as I mentioned, putting everything into one set value call. The second extra command is using Puppeteer. So you would use the get Puppeteer command to get access to the Puppeteer instance, and then there you create a command like set. Make this a little bit bigger. Set domain local storage, and that domain method essentially wraps the website or mocks the website to allow you to access the page without any content. So if I look closely, so you go to the URL and you mock essentially every response to like just a plain text website called Tweet Me. And this allows you, since you're on the same host name as the web app, you can now access, you can access local storage. Then you use the evaluate method, which is essentially like execute some JavaScript on the site, where you use the local storage interface to insert this into the website. And with there's some easier ways to do this now with the mock APIs. So we could actually update this workshop. It's much simpler now, but this is what you can do. And then, instead of having to insert or set the value for these items, you can now just open the website. Then you wait for these items to appear because they're already in the local storage. And then that's your test. You don't need to set the value anymore. And the same for the third task, which this time just uses the mock capabilities that Webdriver provides, where you pass in the API REST endpoint. Here it's the get to-dos. So it mocks the /to-dos endpoint with the method get, and it responds to the values. And the values are defined in your test or in your script as an array. And so you just open the website, you wait for these to-do items to appear. You don't need to set them yourself manually. And this is really interesting when it comes to testing just your front-end application, where you don't want to have the back-end API being involved. So let's end the poll. Let's see where we're at. We've still a bunch of people working on it. So let's give it just a couple of minutes then. If anyone has a question, please feel free to let me know.
Yeah, this is John. I've actually been having issue with the enter command that we put in the set value function. It looks like for some reason in my code, it's not actually making the list and using the enter command. It sets the values in the field and then clears it and then continues to do so for those 3 elements.
Does your set value looks like this one?
Yeah, well, I haven't actually even gotten that far. I was actually just starting with the just the separate commands. Here I can actually just share, and the only difference I have is I kind of changed up the. You mind if I share real quick, or?
Yeah, please do.
Okay, sure. All right, so I basically just have it set up like this. Like the only thing I changed is I changed the quotes, but I was just trying to mess around and see what was going on. Are you able to see okay? Do I need to?
Yeah, I see okay.
Okay. Yeah, so I'm trying to see what other issue there might be that would cause that. Because like I said, it's basically returning this, and then it's not actually creating the list.
Okay.
Oh, what did you start Chrome driver?
Yeah, I mean I have Chrome driver installed, and it should be calling Chrome driver, I think, per this, unless I'm missing a command.
Yeah, you need to start it separately, and you need to start it on port 4444. If not, I think it might be using Puppeteer, and
Gotcha.
eventually Puppeteer doesn't have this translation.
Okay. I got it.
And in
Okay.
fact, there's an issue log for this. So Puppeteer does not understand the primitives of key actions in WebDriver. So this translation needs to have, like, the WebDriver project needs to implement that. So this is a bug on the WebdriverIO side, that the behavior is not the same. And there's an issue for this log.
Gotcha. Okay. Well, I'll try that out then. Thank you.
Just run Chrome driver, and then it should work as expected.
Well, it's Chrome driver and then setting it to port 444, right? If not, if you're setting it by default, it sets it to 9515, and WebdriverIO doesn't catch quite that.
Gotcha. Okay. I'll take a look at that in my own time. I don't want to hold up this thing.
Yeah, and put some comments if you're still stuck. I'm more than happy to help you out through the comments.
Thanks a lot.
Chat.
Awesome. Okay, so we have 2.5 hours left. So for the interest of time, let's continue. Feel free to, you can still continue with this chapter even though you haven't haven't finished the second chapter. You can also just jump into the solution and copy paste it to move forward and eventually finish it after the workshop. So in chapter 3 now, we're going to introduce, so we have now run WebdriverIO with the WebDriver protocol as well as with the test runner. And now we want to bring a testing notion to it, meaning that we want to install and use the Webdriver test runner. And for that, we install the CLI tool, and we run the configuration wizard. You can, when you're running through the configuration wizard, 1 second, I can provide that. Let me just share those. So the question is what's the WebDriver, the Chrome driver command? It's this one. There we go. When you go through the configuration wizard, And you can see on the main page how you get started with that. So right on the bottom, you see how you can install the CLI client. It's at Wdidio/CLI, and then you can call the config. You can either pass in a -- yes. In this case, it will install everything by default. So this will be a Mocha framework with Chrome driver installed and the spec reporter. And then this will always is everything you need to get an example project running, because it will provide you with some example files. So that's up to you if you want to add some example files or if you want to get started manually. Usually that with the example files a little bit quicker. So with the Wdidio test runner, it allows you to run tests in parallel, either on your local machine or later in the cloud. It creates and tears down the session for you. That means that there's no, in your IDE, you won't have any remote or delete session anymore. This is also taken care of the Wdidio test runner. Then it allows you to run your commands synchronously. Again, with that, you'll be careful, because we kind of found out last week that this will be likely not supported in Node.js version 16 anymore, which is supposed to be released by the end of this month and will be LTS sometime next year or end of this year. So if you start a project, I would not recommend to use Synchronous anymore. However, for people who already have built frameworks using Synchronous WebdriverIO codes, commands, there will be a code mod that will allow you to just run it across all your files, and it will transform your test automatically. So I'm pretty convinced that the transition from Synchronous to Asynchronous should not be that difficult. We will also explore with ideas how we can still continue to support synchronous testing. Again, it will allow you to integrate different reporters and services. It will handle your log management. That means it can store all the logs into one directory, and a lot of things more. You find a lot of information about the Wdidio test runner in the docs, in our guide, to see how you can configure the test runner, what frameworks are available, how you use the assertion library, and all these things. So again, we install the CLI, Wdidio CLI, and with that you can call the config command. You go through the wizard, and you can either create your config, your example files, or not, and then you can start your test with the Wdidio command. So let's do that. That should not be so difficult, hopefully. And again, feedback on this workshop is always appreciated. If anything, the idea here is that everything should be really easy and straightforward. If anything is too complicated, we should. I'm always looking for things to continue to automate and simplify things. So for that, I will remove my test file. And to, sorry, to avoid bloating my CPU, I will just copy the node modules files from the solution. Hopefully. That will take a second, for me at least. Sweet. Get this up, so I should have the Wdidio command available now. I do not. Interesting. Oh, okay. I need to copy this as well. Solutions, chapter 3, no modules. Still no. Okay. Okay.
The node modules isn't there, Christian, on the workshop.
But I'm in the live directory, so it should be. I should have everything in here. So the Wdidio command, which points to the build one. Interesting. They essentially just copied what I have in my solution already, and there I installed.
Oh, you had run it already. Got it.
Yeah. Okay. Let's see. And the other thing I could just do is to go in chapter 3 and remove everything I had before. There we go. Et voila, 7.3.0. That's good enough. Cool. So I think you can see okay. I hope at least if my text is too small or anything, please let me know. Then I can make it bigger. So again, npx wdio config. And so it walks you through this wizard, which essentially allows you to set up your environment quite quickly. In this case, it first asks you where your automation backend is. That means where your driver is located. In this case, it's on my local machine, but it could be also in Source Labs or on a Selenium grid. And then you will get some other questions that will simplify the configuration. I usually, when it comes to frameworks, I prefer Mocker. It's the simplest to set up. And I think compared to Jasmine, it is a little bit more feature-rich. And Jasmine or Mocker versus Cucumber, that always depends on your taste, right? There are a lot of people that have opinions about BDD and TDD. I don't want to get into that. So whatever feels better for you. Here, if you want to run synchronous or asynchronous, you can do synchronous. I will do asynchronous given the situation that we cannot continue using it anymore. Here, it asks you if you want to use Babel or TypeScript. If you pick one of them, Webdriver will set up TypeScript and Babel for you. It will ask you where your specs are located. So I will continue with the default. I want to auto-generate some tests, but I don't want to use page objects just yet. That's something for later. I use the spec reporter, Chrome driver, yes, and my base URL is not this one. It's the to-do MVC. So we put this in there. And then I immediately quit because I don't need to install all these things. But now I get at least my 2 files, or at least I don't get them. So we'll do this. And essentially what you do is now copying your code from chapter 2 into chapter 3. And so your code can essentially stay the same. I will add some awaits here because I wanted to use async. So we have a great example why using Synchronous is just so much better. There's no reason why you would need so many async awaits in your tests. And we have a pause in there as well. And I think the expect also needs an await. And can we move these? Because now with the W test runner, we have these $ commands in the global environment. So we can remove the browser dot. And the rest looks fine. Let me see. Describe it, then await everywhere. And that looks good. I think then I need to tweak in the node modules and remove the sync package.
Well, and I was about to ask Christian if people following along are using, you're using 7.3.0, right, on WebdriverIO. If they're using a newer one, I believe 7.4.6 and above, the sync is gone, right?
Mm-mm. No, the sync mode will continue to work until version 8. We will.
Well, rather when they go through the config, when like to do the npx wdio config list, it doesn't ask them if they want async or sync anymore. It won't install sync.
Exactly. Yeah. If they install the latest version, I have already removed this from the wizard.
Yeah. So they won't have to do what you're doing just now. Just kind of for people following along.
Good point out. Okay, so they will then also not get the Wdio sync package because this one is responsible for making this magic happen. But the rest of my config looks pretty much okay. All the default values in there, most of them. So I should be able to run WebdriverIO now by just saying npx wdio. And note now that I don't have Chrome driver running. So there's nothing on my right side. In fact, I can just close this window because with the Wdio test runner and the Chrome driver service, which is defined in the config, if you have selected it in the wizard, where is it? Oh, interesting. It's not even not defined. Okay, I think that's next chapter. That's when we use actually services and reporters. So for this one, we will still continue to use our manual, our local version of it. And since Webdriver will detect that it is running, we don't need to set up anything else, and we can try to run our command. It's starting my browser. It's entering the to-dos, selecting the second one, and it's passing. Beautiful. So let's optimize this a little bit. Given that we have learned in the last chapter, we can just create, can just create everything in one go. Let's optimize this. Enter there. And have an enter there. And we can remove 5 commands, which will save us about a second if you run it on a cloud vendor. Then the same code that we had before. And let's run it again just to test it, and then see how that should be still passing. Perfect. Now I want to show you an example is why it's important to have a little bit context about async await. So let's say I change the expectation here in my assertion, and I remove the await because I forgot about it. This test is supposed to still pass now, because we are not waiting for the promise to resolve, and we prematurely just continue with the test. There we go. Nothing is failing here because the expectation, we have not waited until we have not waited for the result of this expectation. So this happens if you wait, if you forget and wait, and while the sync command was a very nice feature, and this is why we will probably spend some time to make this still work in the future. So let me now just add an await and just run this again. And now the assertion library has enough time to fulfill the request and see that the promise is going to be rejected, and it can then reject or throw an error to make the test fail. And we already see that the test takes much longer because the assertion library automatically does retries. So if it cannot find the expected result, then it does retries, and you can modify these retries. And at some point, I think after 5 seconds or so, it will break, and then will give you the results of whether or not what was expected and what was received, and where the error was. And it points you also directly to the location where this happened. In this case, we have a test.js in line 20, position 29, which would be here. It points to the to have text call statement, which was not 2 items left, but 3 items left. So here you see how important it is to make sure that every command that you execute has an await in front of it, including the assertions that you write in your tests. Great, let's make sure that we're in the good state here. Oh, it's still failing. Interesting. Oh, I didn't save probably.
Yeah, it's still 3 there.
Two items left. Oh, yeah. I was of the idea that it's supposed to be 3 items left, but it's actually 2. Run it again because it's fun. There we go. Passing. Okay, so let me run a poll, please, to just find out where we're all at. Let me see. Number 3. So please let me know where we're at in terms of progress. Again, this class was about introducing the WDO test runner and porting what we had before into a test and run it successfully. Our next chapter will be about using a custom or using reporters and services. So here we will integrate the Allure Reporter. We will finally add Chrome drivers, so we don't need to do it, or we don't have to run it ourselves anymore. And we have to extend our WDO config to generate the Allure report. I'm not sure if you know about the Allure Reporter. It's an HTML reporter that creates a nice little UI for you to follow along how your test progress has been. If you use Jenkins, it has a nice integration there. I think it has also integration to Bamboo and a bunch of other CIs. So it's a pretty popular reporter, especially for the end-to-end world. It gives you a dashboard, gives you details to your test runs. And the Allure report itself only generates XML files with information that it captures throughout the test. In order to generate the HTML, you have to add a little add-on that you find in the docs at the bottom of the page with auto-generate report, where you see an example that you can essentially copy-paste into your solution, which is installing the Allure command line and setting up an on-complete hook, which will be triggered when all your tests have been finished, and so you can exit. It then generates the HTML out of these XML files. So let me see how we are doing. Okay, we are still the majority, still working on the third chapter. Is there anyone we can help with? I mean, otherwise we can still give them some time. Again, I was not expecting to get through all of them. In fact, it's not, for this workshop, it's not really important how far we get, because we can always, the workshop is on the internet, so we can always continue it after this workshop. And if you have questions, you can reach out on the GitHub channel or raise an issue or contact us if you have question on certain chapters. So let's wait 5 minutes. I will use that to take a little break, and I will be back in 5. Already talking about chapter 4, which is about the services and the reporters. So we want to integrate 2 of the most used services and reporters, 2 of the most used plugins in the Webdriver ecosystem, the Webdriver Service and the Allure Reporter. And then we want to integrate it into, we want to generate the report in our complete hook. And we want to also report the WebdriverIO logs and Webdriver logs into a directory called logs. So just go ahead, install the service and the Webdriver service and the Allure Reporter, and then integrate it into your Wdidio config. Go check the chat. Okay, chat looks good. Okay, so jumping into the IDE. All we need to do essentially is installing the services and the reporter. Then for the logs to be stored, there's an option called Puppeteer. If you look into the WebdriverIO docs, we see this output here being defined there as a way to store all the WebdriverIO logs, the verbose logs that we've seen before. Instead of the standard out, we put them into a file, and that will help us to work with this log file after the test has been finished and store it eventually on the CI or upload it to a bucket, whatever you want. And then we define the Allure, both plugins that we have installed in our Wdidio config under the reporters. We already see a spec reporter there. Now we are adding an Allure reporter. And here what we can do is defining the Allure Reporter comes with an option that allows you to specify the report directory. So if you look into the Allure Reporter documentation, you see that we can define the output here, as well as a couple of other things. For us, for now, it's only important to define the output here. And in order to make sure that we know which output tier is meant, we will prefix the dir name in front of it. So if we would just write Allure results, I would usually not know, if is the test runner going for the relative part, or where does the test runner going to put the results? If we use an absolute path here, which happens if you use dir name and concatenate with the directory name, then we are on the safe side. It's also nicer to define this result directory once and use it not only to define the output tier of the Allure result of the Allure Reporter, but also use that variable to tell the generate function at the end using the Allure command line plugin to where the results of the reporter are located. Again, in the Allure Reporter, there's a case that the reporter itself only generates the XML files as well as the JSON files that it needs to, and we will look into that in a second. So we need a tool which you find on npm called the Allure command line, which you can use programmatically in your Wdidio config, and we use it to generate the HTML from the Allure Reporter based on the files that the Allure Reporter has generated. So, and I've already run this. You don't need to change anything in your files because we just enhancing our configuration a little bit. And if you run your test runner, you will see that you have a couple of more directories now. We have, since we defined the output here, we have a logs directory where you now see all the information that we're usually printed out in the standard out. We now see that in a log file for the main runner, for the parent runner, for the worker that was executing or running the spec file, as you can see here, and for the browser logs, which is an old JSON wire protocol command or protocol endpoint, which is likely not to be supported. It's still available in Chrome driver, but not in Gecko driver, I think, anymore. So, but what you at least should see is the logs for the Chrome driver, even though the Chrome driver logs are empty, but for the worker and for the main runner. What you also will see is the Allure results directory, which contains all the results and the payload of various commands that we have been running in our test, all in JSON form and in form of XML. This is usually not useful for us, but as we have integrated the Allure command line, we are also getting the Allure report, which is the generated HTML page. So then usually if you have a CI/CD system, you can make this an artifact and make it allow it to be downloadable by your CI. So your CI stores it, and you can then view it on your local machine. I think the Allure Reporter has integrations into the common CI/CD platforms. I know for Jenkins, there's an Allure plugin that allows you to view the website directly from Jenkins. So in order to just show you how the report looks like, it's like we go into the Allure report directory and then run a static web server. Then going back to the browser, we can open that address and see a generated HTML page, which has not much data as we just started our integration, but we see that it has a suits page, which represents our last test run, and it shows the test with all our commands that we've been running. and we can look into the request, what parameters have been posted, and also into the response. Yeah, so for the last commands, we see that we called the get text command, and we got 2 items left. All right, this is essentially it for chapter 4. If I correctly read out, you can install the static server by installing the HTTP-server package globally. If you have a different static server that you can just spin up, use that one. I think the HTTP server package is not maintained anymore and has some vulnerabilities, which is not really important if you just are on your local machine. But for me, it is the simplest server that exists right now. So you can use that one to just spin up quickly a static web server that can serve your Allure report files. And eventually, if you integrate that into your CI/CD, then this can be displayed by the CI environment or wherever you can upload these reports to an S3 bucket, make it available and visible there. There are multiple ways you can go about this. All right, I think that's it for chapter 4. Let me prepare the poll. Well, let me launch the poll so I can see how far we're at. So please cast your vote, and we can either continue or wait a couple of more minutes. If anyone has questions, feel free to just unmute yourself and ask a question, or post a question into the chat or on Slack. So let's give some time for the poll. Also, let me know if we are going too fast or too slow, so we can adjust the speed as you wish. Let's see where we're at. Okay, so still some people working on chapter 4, so we have time to continue working on it. Again, let us know if you have any questions or struggle with some issues. We're happy to help.
Actually, I do have one question, Christian. Is the WDIO Chrome driver service, is that required to run the Allure Reporter?
No, they
Okay.
are both independent from each other.
Gotcha.
That's the nice thing about these independent plugins. It's like a Lego set that you can just pull together as you wish. And there's so many different ways how you can configure your testing environment and your test framework. And the nice thing about I feel like the Webdriver ecosystem is that there are so many services and reporters that allows everyone to just pick their environment and their setup as they wish and they like to work with. Seeing some questions in the chat. Yes, the Chrome driver service is only for Chrome. There is we have a service called the Selenium Standalone. Where do we have it? Oh, on the bottom. There's a service there. We have a service for other drivers, I think, which is, let's see, Chrome driver. We have 2 for WinApp driver, so for Windows apps or different driver. I don't even know what that one is. But if you want to have a service that can start not only Chrome, but also Firefox, Safari, or Edge, then you might want to use the Selenium Standalone service, which comes with all the drivers included. So if you don't have the driver installed, it will download it for you. If it's, if you test on Chrome, or if you test on Safari or Edge or any other browser, it will download the driver for you and start it and connect your session accordingly. So this one comes with all the drivers. The thing with this one, though, is that, which was the reason why I did not choose this one, is that it has this Java dependencies for some drivers. I think that's at least my understanding. So in order to not have people to install Java, we just go by Chrome driver, because Chrome driver is just a binary that can be run anywhere. And for the Selenium Standalone, I think it starts a Java file to also be able to handle multiple drivers at the same time. But you can use that it's the same way of integrating it into your services. Yeah, and you can just test Safari with it. Obviously only on Mac machines, because Safari per se is just available on Mac. I had recently a question by someone in the community if it's possible to run Safari, to automate Safari on Windows, and I think that's not possible. The folks from the Playwright framework, they can only achieve that by giving you like a tweaked WebKit version, which is not a real Safari browser, which might work for your automation purposes, but you need to just know that it's not actually a Safari browser at the end. It's close to something like a Safari browser, but not this Safari browser. So if you're on a Mac, you can just install the Selenium Standalone and test with that. And the only thing that you need to change, you maybe do this as an extra task. So replacing the Chrome driver service with the Selenium Standalone service, simply by installing the service and replacing the configuration, and then just modify your capabilities to use Safari, for instance. The Selenium Standalone service might be a little bit tricky to set up, because it requires you to define the versions if you don't want to use the latest one. So there might be some opportunity to improve the usability of the service. If you don't provide any default values, it should work out of the box, but I'm not entirely sure of that. It usually should always install the latest driver. If you are on Mac, Safari driver will come with your OS, so you don't need to install or download Safari driver. It's already on your machine. But for Firefox, Edge, and Chrome, we have to install and download the driver.
I have a question regarding Allure. I'm actually seeing that I get the output files at the end, the Allure results, basically the default area that's on that comp file. But I'm trying to look for the HTML, I guess, output that comes from that. What file do I need to access to do that?
So you get this tool thing, all these JSON things?
Yeah.
Perfect. So the last step is for you to add this onComplete hook, which if you go into the Allure Reporter documentation, you will find it and can almost copy paste it from there. So it's in the Allure documentation on the section to auto-generate the report.
Okay. Yeah, I actually have that in the comp file. I think I just basically took your comp file that's in chapter 4, included that, but okay. I'll take a look at that.
Perfect. The next chapter is going to be about performance testing. And so for that, we will integrated another service called the Devtools Service, which is our service with the Google Lighthouse integration. And then we want to emulate the user experience for an iPhone X with a 3G connection and test if our speed index, which is a performance metric, kind of an outdated one, to be honest. We should update that maybe. They're better used one these days. But the speed index was a good metrics a couple of years ago to find out whether or not the page is loading fast. And then we modify our, we run that locally, and we want to run it on Sauce Labs. Because Sauce Labs provides these capabilities also. And we need to do some changes for that. So let me enter poll. All right, we have the majority, the big majority to continue. So I think we're just going to continue with chapter 5. And if you're still in the last chapter, you can either save there and continue with us, or just continue on your pace. And this chapter can also be skipped and continued or tackled after the workshop. They are nicely separated. So you don't need the performance testing chapter to continue with the next chapters as well. All right, so Webdriver provides a lot of integrations to platforms as well as to tools like Google Lighthouse. I can show you how Google Lighthouse looks like. All right, I think, yeah, you should see it at the right, on the left side of my browser screen. So I've opened the Chrome DevTools, and there in the tabs, if you have big enough or you make it on Windows, you see the Lighthouse section. And Google Lighthouse, as I mentioned before, is a tool that helps you to audit your websites for performance, progressive web app, for different categories, performance, progressive web app, best practices, accessibility, and SEO. And it comes with some community plugins. Right now, there's a publisher ads that is shipped automatically, but I think the community has a bunch of other plugins that you can use. And you can choose if you rather want to do the audit on a mobile or a desktop device. The difference here is that if you pick desktop, then it will just run on your browser here. If you pick mobile, then it modifies your browser to mimic a mobile device. That means that it changes the user agent to pretend it's an iPhone, I think, or like a mobile device. I'm not sure which one. And it modifies your dimension of the screen to mimic the dimension of that specific mobile device. So essentially, you're not testing a mobile device, but it's emulated. It's an emulated mobile device. So the resolution is like a mobile device. The user agent is like a mobile device, as well as the CPU and network capacities mimic a mobile device. So for performance testing, I think there's no vendor so far that allows to test on real mobile devices. Those are all emulated, and it's usually sufficient. I think it would be still great to have that feature, but it's difficult to actually execute this on mobile. So we just keep it for, let me open our Vue app. Open the DevTools here. Need to bring it in. So now you see it on my right side next to the Vue application. Opening Lighthouse. That's fine because it used IndexedDB, interesting. And I will just include all the categories to test. And then I click on Generate Report. And so what's happening now is Google takes over, or the Lighthouse takes over, which is an add-on for Chrome DevTools. And it modifies the app, and it does some checks. It disables JavaScript. It checks for various of viewports, and just to search the application in general. And what we get as a result is a nice report about the performance, accessibility, best practice in SEO. And there we see that we are doing pretty good on performance side. We have some cumulative layout shifts, but that's fine. It gives us also some information about how we can improve the performance of our application. Then we're doing kind of okay in the accessibility section, much better in best practices. SEO is okay, and it finds out that our to-do MVC is not even, it's not a PWA app. So there's some, the PWA app is just it's a web application that follows some best practices. For instance, it has a web manifest, so it can be installed by devices locally, so that it's also offline available. So when you have that manifest, your device can download all the assets and allow the experience of the application in offline mode, and a bunch of other things that Google Lighthouse provides. And so what we want to do in this chapter is to tackle the performance part. And it's nice to run Google Lighthouse in DevTools, but essentially it's when we want to run this in CI/CD, we cannot, log into the VM and do this manually. We want to do this in an automated way. And that's why we have the Devtools service. For that, let's go into the service documentation. All right. So DevTools Service is like the Chrome driver service, just a service, it's just a package that you install. It's called @wdio/DevTools Service. You can enable it by adding it to your service list. And then you see in the first section how you do the performance testing locally. There's a command called enable performance audits that you can use to configure essentially the same things that I just explained with the Lighthouse report. You can configure what kind of capabilities your audit should use, if it should restrict your CPU or network capabilities, if you want to run it on a specific mobile device. Let's check the options for that. You can see an example here where you can choose a mobile device that has cache enabled but has a 4 times CPU throttling and a network throttling of 3G. The form factor, changing to an iPhone viewport, you can use the device emulation, which you can see here, the command. Google Lighthouse provides a various of predefined viewports and devices, starting from BlackBerry Playbook to iPhone to Pixel. And you can also define your own viewport and your own user agent if you want to. But I think, if I'm correct, in our objective, it says that we want to test and emulate on a mobile device on an iPhone X with a good 3G connection. That's our goal. So let's go to the docs again and look at the example test. So what we want to do is essentially we enable performance audits, and this will turn on, this will enable the DevTools service to capture the performance for every page load that we do. For instance, using the .url command, where we actively navigate to a page, or when we, for instance, click on a link and then we get through the click to another page. So for both things, we get performance reports. What you need to know doing that is that capturing the performance takes some time. Chrome does a lot of, or Lighthouse does a lot of things in the background, from waiting until the app does not do any network requests anymore. It waits until the CPU is idle, until there's no, until the app is finished loading, and that can take some time. And you don't want to include this into your general functional test. You want to have a specific test, a test suite that is only looking into the performance of your application. If you think about the testing pyramid, you have your unit test at the bottom, your integration test in the middle, and then your end-to-end test at the top. So think about performance test as the sprinkle on top of the end-to-end test, like a little small test that will help you to identify the performance of your application. And you run them, of course, in a separate step. So if your application is functionally not okay, it doesn't make sense to run any performance test because you would not ship a broken website anyway. So we only want to do these performance tests when our tests are finished, when our functional tests are successful. So let's copy that in pretty much. So let's switch back to our IDE. Let me prepare my solution. I will move things that are in here. I will move this. Let's just keep it around. So here you can already see that I created an extra file for performance testing, which I removed. So this is our test that we had before. It's now synchronous, but that doesn't matter. So we can go into chapter 5. Okay. 0.5, great. So again, we want to run our performance tests separate from our end-to-end tests. So that's why I create a separate, performance file. Test performance. It should load fast. All right. I will continue with the sync way. If you have started with the asynchronous approach, stick with that. Just don't forget to put the awaits in front of the commands. So what I'm going to do is, as seen in the docs, we want to have a before hook, or before hook essentially, that allows us to enable the performance audits, and the after hook to disable them. So let me copy that out, actually the whole thing. And copy this in here. Perfect. And so then our task tells us that we want to test the performance of an emulated mobile device that mimics the browser of an iPhone X with a 3G connection. So we've seen already that in our device simulation. So for one, we can essentially copy paste this here. So we have a mobile form factor, a CPU throttling of ×4, and the network throttling back to good 3G. Copy paste that into our IDE. So that we do before. And I feel like to disable the form factor, actually forget, I'm not sure how to disable the device simulation. There must be a way, but I'm not sure right now. So we just leave this out. I mean, we end after this test anyway, and I would also recommend to have really a short performance test. Don't have a large spec, just have a lot of little performance tests running in parallel, so that we can speed up this additional CI pipeline step. So this time, instead of doing JSON.org, we want to do our Vue application, and we have a command called getMetrics that's why where that's will give us the metrics on various of various performance metrics. Let's go into what those are. If we go to the get metrics command, let's see. All right, we have a bunch of interesting performance metrics which start from time to first byte, which is the metric that tells you how fast the server was able to respond. So it gives you an idea about how fast your backend network is to respond with the HTML page. We have the first visual change, the first paint. The difference from that is that the first visual change is whenever, that's actually interesting. I think the first visual change is whenever something visually changes, and the first paint is when actually an element, a DOM element is painted on the page. So that's, if your background changes, that doesn't really count into first paint because it doesn't reflect an HTML element. With things like largest contentful paint, last visual change, first CPU idle, first interactive, speed index, and cumulative layout shifts, and all these metrics. I don't want to go too much into that, but they all give you a different idea about how your page loads. And I think a good general metric, which is not here, but the one that we have here is the speed index. So speed index is kind of like an average of all the metrics, in the sense that it gives you a good indication about the general loading experience of a user. It's not the average of all these numbers, but it's a metric that captures the performance in a way that gives you a good average experience. And so that's why we focus on get metrics for this chapter. There are also other tasks that you can use to get other information about, the number of requests, the number of tasks, the JavaScript tasks that took over a specific amount of time. That can give you an indication if there are, any blocking tasks that will stale your user experiment. Let's say you have a task that computes something and it takes over 500 milliseconds. In that 500 milliseconds, the user cannot interact with your application at all. And that is seen as some bad experience in general. And you get information about the worker threads, about all the tasks. You can even, I think, get into the whole browser engine logs that are available. Okay, going back to our IDE. So what we do here is essentially we open the URL, and instead of using the assert package, we use our expect WebdriverIO assertion library, and say expect speed index to be below, I think. Need to check the docs. Need to look into the expect logs to see what assertions we have to make this correct. To be lower. Oh, to be less than. Okay, perfect. So we want to be the speed index to be less than 1,500 milliseconds. And we want to have the performance score, which is a weighted mean of the speed, a bunch of 5 different metrics. I don't know in my mind which these are, but it's a weighted mean on 5 of the metrics that I just showed you. And it gives you a general indication about the score. If it's 1, it's perfect, as we've seen in the Lighthouse report. If it's 0, it's really bad. So we assert here that the score is to be Now I need to check the logs, the docs to be higher or above. Ooh. Let's find out. Be greater than, obviously. To be greater than 0.95. Have like the thing with performance testing is it's not that you get every time the same results back due to your CPU variance and due to network changes and little network bugs. You will not always get the same results. So the question is, how reliable is the performance test result when the test is running in the cloud, like Sauce Labs, comparison to local? That's a good question. We had a lot of customers using the Sauce performance capabilities, and we're asking why the performance score on Sauce Labs is different than their performance score is on local. The difference is that our VMs in the cloud are not as beefy as your local MacBook or laptop, whatever you have. So the performance score is lower. What we are interested in here is if the performance score changes. So once we have detected the performance score from running in our CI, we stay with that, and we just check if it decreases or increases. And at Sauce Labs, at least, I did a bunch of tests to check how reliable these tests are, and they are indeed changing by like 5 to 10% sometimes, depending on which metric you're looking at, which is something that also happens for local. If you run locally on Lighthouse, the fluctuation is less, but there's at this point it's not much we can do because we run over the internet. We access your app on your network. It's much more end-to-end than running this on your local machine. So while we're trying to keep this number, the variance low, this is what you at the end, that's what it is at the end. So if you are able to run these, performance tests headless in your CI, that is also an option that you can do and might give you more reliable results. But if you introduce a performance bug that really, changes the experience of your users, then you will find them using a cloud vendor like Sauce Labs as well as on local. Okay, so we have our test ready. It opens the page, then it calculates the score in the backend or in the background, and we then get the metrics and we check if these metrics are within our expectation, within the range of expectation. All right, so I think that looks good. We can look into the Wdidio config, which has the same configuration as we had in our last chapter, with the difference that we have now Chrome driver and Devtools installed. That's about it. So I will run WebdriverIO now with the --back flag and say I want to run the performance back instead of the tests back. So let's see what this will result. So if you could see my browser now, you would see that the application is now much more smaller rendered because we are emulating a mobile device. And then it finishes loading the URL and stays a while like this because in the background, the Lighthouse, the Devtools Service is busy compiling the test results or the results that it has captured. And usually it should take about 5 to 10 seconds. Oh, interesting, I still have a lock in there. It might take longer. There we go. And it passed, which is amazing. And so we can look into the logs to see what kind of results we got back. So we're looking into our, oh shoot, I didn't get them. So let's look into the Allure result report. It's still a bug. Report. Look into there. To see what kind of performance result we got back. Opening localhost again. So getting into just to test the performance of our Vue application. It only has a URL command. I think because the Devtools command is not logged as a Webdriver command. That's interesting. Okay, then let's do something else. Let's go back into the IDE. Okay. We don't get these logs, no. Okay, what I will do is just log the metrics to see the other ones that we have and the score, and just run this again. So there's a little bug. I think it's already logged that the worker logs are being cleaned up for some reason, and that will be fixed soon. So I'm going to run this again with these console log statements so we can just see what the actual results were. Again, if you make sure that you put in the weights in front of every of those commands, because even though it's not a Webdriver command, but these all are asynchronous operation. Capturing the scores, calculating the scores are all asynchronous. So it should look like something like that. Putting in a weight in front of the expect as well as in front of the get performance score and get metrics. And don't forget the async as a prefix to a function. Oh, this was should go. So, and then we see that we get a bunch of metrics back. Interesting in this one is this speed index, which is far less than 1.5 seconds or 1.5. I think it's not supposed to be a second. So response time. And lastly, this overall gives us a performance score of 1, which is essentially almost the same as we got in our local Lighthouse audits that we did in the Devtools panel. So it comes pretty close to the original, given that it's essentially the same way of running things. Just here, it's integrated in WebdriverIO rather than using it from the Chrome Devtools application. And that's about it for the chapter. I think there was an additional task that I would skip for time purposes. But I can just go into its solution, modify the test so we can run it locally as well as on Sauce Labs. So, okay, so the thing with these features is that they're heavily relying on the Devtools protocol. And right now, if you run tests on Sauce Labs, you only have access to the Webdriver protocol. That means that you cannot create a direct connection to the browser that is running in our data center, which makes it impossible to use this feature through the Devtools service. But what you can do is, so Sauce Labs provides capabilities to run performance tests through Webdriver commands. So just a quick Google search on Sauce Labs performance testing, we get to the performance testing page, but I want more interested into the docs, and you will see the commands that you can use. So for one, to use this, you need to enable performance by putting extended debugging and capturing performance flag in your capabilities. And then you have some custom commands, some commands that you can use to trigger these performance metrics. There's an execute command where you can pass in a custom log name, and you can get the source performance from it, and you get essentially the same metrics. It's just that the information that you want to trigger, these performance metrics are wired over the Webdriver protocol rather than connecting directly with Devtools. And so I can show you the solution in the IDE. You can find the solution in your solution directory. I'm interested, I've deleted that file, so let's look into GitHub. And the solutions, chapter 5, I think. Yes. So again, here, as I mentioned in our beginning presentation, is that we have a config dedicated for running tests on source. And here we define our user and key, as well as our custom source options to enable performance testing on source. You should be able to access it with a free trial account if you don't have an account for source yet. And we inherit from the main config file, and that will do it. That will enable it for running it in source, but then the test will be a little bit different. So for source, those are the same tests that we just run. This time separated in two tests, one for opening the application, the second for asserting the metrics. The extra one is here, right? So we have two ways of running the test, given that running the test on source is a little bit different, given that we have different commands. You probably have seen we use different protocol commands. So rather than using the Devtools command, the commands that are propagated by the Devtools service to the browser object, like get metrics or get performance score, we use Source Labs protocol commands. These are called throttle network, throttle CPU, as well as get page logs to get the source performance information. You find more information about all the protocol commands for source in the under the protocol section in the API, on the API page, and then you see for Source Labs these commands again for running them on source. So the idea is to at some point merge them to one, to have one seamless condition. Until we are at this point, we have to do this little trick where we define a function or where we define a variable that is based on the isSource flag on the browser. It skips the local or the remote test. So if we are if the isSource flag is enabled, the one local command skips the test. If the source flag is enabled for the run source variable, we run this but skip the local test. So now we can say we have a test for running it on local and one test running it on source. And it's a way to have like these two tests for running locally versus remote in the same file. You could also have, again, a Source Labs configuration as seen here, and just pointing to a different set of files that would do the same work, would be less complicated, because this kind of way of running tests looks a little bit weird, to be honest, but it's a way to do this thing. There are multiple ways to run this, right? So this is essentially it for chapter 5. So let me get a quick idea by running a poll. how far you got, but I think we will all wait a little bit more. So where we at, chapter 5. So I'm going to launch this poll. Just let me know where we're at. If you have been able to run this performance test, at least locally, that's the most important part. And again, it just should demonstrate you the capabilities of running performance tests locally. I recommend to try it out if you have a CI machine that supports spinning up a browser, even just on Linux, that's fine. It's easy to integrate a performance test in there and see if there are any major bugs that cause user experience issues. Okay, let me know in the poll where we at. The next chapter will touch on this. It will go into the PWA testing, and we will use the same setup, but use a different command to find out that our application is not a valid PWA, as we've seen in our Lighthouse report. Okay, let's see where we're at. And poll. All right, I think we have still 2 folks working on it. I think that's fine to move on, given that the chapter 6 is really small and should be easy to achieve. In this case, again, we test the PWA properties of our application. If you have not heard about PWA applications, it's essentially, it defines a set of best practices for building web application. And you can read about this on the web.dev documentation, how you can build those PWA apps and how they are, what the advantages are, how you build the web manifest. And it uses just modern web interfaces and web APIs to allow to build apps that are working fine, not only on desktop, but also on your mobile phone, and can be installed by a mobile phone and all great things like that. So let's imagine we have such an app and someone forgets to deploy the web app manifest, which is essentially the manifest that defines all the configuration about our PWA. And from one deploy to the other, none of the users will be able to use your application offline or will be able to download it anymore, enjoy any of the other advantages of PWAs. That would be an undesired experience, not only for you as a developer, but also for the user that uses your application. So that's why having this additional check in the CI pipeline makes totally sense. And it's also really fast to do because it's just essentially one little check that you add to your functional test even, because it's really just some scripts that are run to find out if the PWA is correct. So let's see. Back to the workshop. The workshop outline recommends us to use the PWA, the check PWA command, which comes with your Devtools Service moved in. It has a past property, which you can use to assert whether or not all the PWA factors are, or all the PWA attributes are being valid. I think they are not every PWA attribute is being checked. I think it doesn't check if your app works offline or something else. But I think there's just like 80% of the checks are being done compared to the Lighthouse report. But it's already giving you a good idea of whether or not the status of your PWA app works. For that, let's switch back to the IDE. For that, we just essentially use the same code. Well, I will use the same code. In a real scenario, I would recommend to put this into a different spec file so you can run a PWA test for your, like just one PWA test rather than running a whole test suite or mixing it with functional tests. because that, again, it should be separated from your functional test, even though you can run it with your functional test. But separating those makes sense because if you have a bug in your application, you don't really care if it's performant or if it's a PWA app. You want to make sure that your application always works flawlessly before doing all these additional checks afterwards. So what we do here is to get the PWA results. So what I do is I say browser.checkPWA. Again, this command is populated to the browser scope or browser variable because I have the Devtools service added to my config. Okay, the checkPWA command does not take any parameters. It's fine as it is. It can take parameters. If you want to just check for certain factors, you can limit what you want to look for. But if you don't pass in anything, it just checks all the components of your PWA. So let's say we want to look into the results, and we also want to expect, or we do expect, that the results do pass. That looks good. We can remove this. I think that's about it. A small little check, one single command to add a lot to the coverage of your end-to-end or of your functional tests. So let's see. Interesting. And I was afraid of that. Let me check if I have it here. So there was a bug in the earlier version of Webdriver that I have. If you have the latest version, you should be fine. Let me check if chapter 6 has a newer version. It should. Okay, 731. Let me real quick check if the fix was already in there, because I don't want to install the dependencies because then my computer will likely freeze. 731. Okay, it's in 740. Well, that means I have to install just the PWA service again. Okay, going back to chapter 5, I guess. So I'm reinstalling Devtools Service before I remove my package lock and the service itself. Removing the package lock because I'm not sure if my update will update if it has the version defined in there. So just to be totally sure. Almost there. In the meantime, I'm gonna start the poll to see where we're at with chapter 6. Please cast your vote. I think that was a pretty quick one, given that we already had almost everything that we needed. Devtools service in place. We just needed to add another file or add another test to do the PWA test or check. And I'm almost there. right. Oh, finally. Yes, perfect. Starting from and passing. Okay, interesting. In this case, our Vue is a Pwa app. Let me see, just to make sure we're on the. Let's take definitely a Pwa app that is not one. JSON.org is not Pwa.
I think you might need to enable the performance audits first, right?
The what?
Enable performance audits. You don't have that right now.
Yeah, no, the check Pwa app should not be depending on that.
Ah.
Because it's not doing any, it has not doing any performance things. If I'm, and the Pwa, the command in the docs also doesn't say that. I mean, let me try that just to be sure, but that would be a bug then, because the JSON, let me just enable that. Okay, let me just check on the config. Well, that looks good. Maybe I was just so convinced that this Vue application is a Pwa that I was completely not seeing it, that it's not. No, that's a bug. I think any page will do, even like, I mean, you can make this fun experiment. Let me see where we at with the poll. Some people still working on it, so we can do this quick experiment where we just hook into the Devtools package and see why we're getting this weird results. It could be related to, because I installed a different version for the plugin instead of just updating everything at once. That could be it, but who knows? Let's see. Just left a little bit of live debugging here. So what happens in the background is that the service captures runs a bunch of scripts that gives us the information about all the things. And based on that, we should see we have a web app manifest that's 0. We have installability errors. So there's something wrong with the way how the service audits the results from the gatherer. We can look into that as well. I don't want to spend too much time on here. Update commands, audit Pwa. So we have the audits. Let's just look for this one. See, that's the beauty of a live example. I mean, it was actually me not seeing that this is wrong. So let's see what we have here. Web app manifest 0, yeah, as mentioned before. Oh, the audits, okay, then. Oh, I think I have an idea. Let's just remove the filter. I think there's some problem with the passing in the parameters. It filters all the audit results because something with the parameter does not wrong, and that already looks different. It takes also some time. Come on, what does it take so long? Retry, just in case. Oh, okay, I think, no. Shouldn't, oh, there we go. All right, okay, now we got it. So now we have true to be false, and we see the details. So there's a little bug in there that I will report after this. So we see that it's not installable. We have a score of 0 there. We have a score 0 for service workers. We have a score 0 of splash screen, which is not defined because we don't have a manifest. We don't have a themed omnibox also defined in the manifest. We have a 1 on the content width because our, in this case, the JSON.org had a responsible design. But the report, the viewports were still not all supported. There was no attach icon. There was no maskable item. And just for the sake of interest, we have an open source website. It's the website of our team, and that one's supposed to be in PWA. So let's check about that. Actually, we can now remove the performance stuff that we had in the beginning. Okay, let me rerun this. So now we can remove this because we don't need performance test for the PWA check, and this makes it much faster to run. Loading it up, closing it down, and we have a passing results. As expected, looking at with an installable screen, a service worker, splash screen, and themed omnibox, content width report, and an Apple Touch icon, and a master icon. So, yeah, I'm sorry that there was a bug in there. There will be for sure fixed either tomorrow or within the upcoming days, but you get the idea about how this will and can work. It's a little simple script that you can run in your CI locally. Again, this will not work on Sauce because we don't have access to the DevTools protocol. But if you test those things locally on a local Chrome in your CI, I mean, I think there are a bunch of Docker containers that provide a Chrome pre-install. This is really a nice little check that you can add. Okay, let me run another poll. If we should continue with, we are in chapter. So let me run another poll. Please cast your vote to see if we should continue with chapter 7. Given that we are half an hour till the end, I think it makes sense to, if any one of you wants to have or tackle a specific chapter, we can do that. We can just continue with a custom reporter service, which I think is not that exciting. We could do a CI/CD integration, the Sauce Apps integration, which is simple. So let me launch the poll if we should continue and create another poll. Which chapter we want to run next? Given that we don't have more time at our hands, so we are at PWA testing. Let me create this poll real quick. and you let me know what we're gonna do. Visual regression testing, TypeScript, save, and launch that Pwa as well. All right, majority says we should continue again. You can still go back and continue on the previous chapters and the current chapter. But let's make use of the last of the time. Please cast your vote on the chapter. You can feel free to click on multiple if you're interested in multiple, and we just take the one that's voted the most. Democracy. Okay, everyone casted the vote. So let me enter the poll. So we have CI/CD integration, 9 votes, and the other one are around 3, 4, and 1. Okay, let's do CI/CD integration then, which is chapter 8. Awesome. So in this exercise, we want to run things in continuous integration and delivery environment. And for this exercise, we use GitHub Actions because it's free. And it's free. It's easy to set up. So I hope you all have a GitHub account. See that I should put this on the prerequisites. If not, real quick, create one. I think it should not take many steps. And then create an empty repository and push all the files to that repository that you have. And then we can start building out the CI/CD integration. So the objective for this chapter will be to set up a GitHub workflow to run tests on GitHub or in GitHub. And so have a config to make it run locally and create a config to make it run in CI so that we have an npm command to just trigger quickly the test locally. And for our workflow file, we have a different command. And then as an extra step, we want to bundle our Allure results as a workflow artifact so that we can download it in case the tests are failing to be able to look inside. And given that I already have this workshop on GitHub, I will just go and create an empty additional workflow file. So if you're in a GitHub repository, you can define, there's a documentation page about GitHub Actions where you can essentially learn everything about it. What we want to do is create our own first workflow file that bring back into the IDE. And in GitHub, in GitHub, you will find in the documentation that you can define your workflow files in a folder called .github and a subfolder called workflows. Just to show you that a little bit more, how that will look like when you are in GitHub. So if you're on the root of your repository on the main page, you have this little .github directory and workflows subdirectory. And there you can put in YAML files and you can name them whatever you want. They're going to be picked up automatically by GitHub, and you will see all the runs being executed in this Actions tab. So the nice thing about GitHub Actions compared to all the CI/CD systems that I used so far is that the way how you define your workflows is pretty easy, straightforward. It is based on Docker containers. So you can easily mix match different environments to do certain things, which is really nice. And if you don't have GitHub Actions, or if you don't use GitHub, I think there are tools that can emulate this environment, even for your Jenkins and other CI/CDs. But generally, today, every CI/CD allows you to just pull from the Docker file, execute some things, jump to the next Docker file, do some things there, which is pretty convenient. Convenient way to automate things. Going back into the IDE, let's create a workflow file. We call this file test.yaml. I think it doesn't matter if you have an A in there or no. And now you fill in the information for that workflow. So it all starts with giving that YAML file name. So you can say name equals my CI/CD tests. You see that if you use things like the S code, it will already tell you that it will already detect that it is a GitHub workflow file and will give you information about what's failing or why is it not working. But this way, we see that we have some missing information. Let's see, going over this, we need an on and an jobs. So we need to define once when this workflow is being triggered with on, and we need to define the jobs that are being run when this event happens. So in on, you define essentially the events that should trigger this workflow to be run. Again, you can define as many workflows as you want, and you define, for every workflow, you can define that it should be triggered by different events. And so in this case, I want to just do it like this. It's a YAML format, so if you want to define a set of things, you just start with a dash. In this case, I want to run my workflow whenever a push happens, as well as whenever pull requests happen. It even like gives you all the possibilities here as a suggestion, which is nice. And then I think you can define this define this even more and say, okay, I want to only run this when a push event happen on a certain files will change, things like that, which is very nice and convenient. Then we define our jobs. So jobs have a step essentially. So you can name a certain step in your workflow and say, okay, this step has a bunch of things that it should run sequentially. But then there could be a deploy step, which runs after the test step or in parallel of that. So you can define essentially multiple things that should happen at the same time or in parallel. That's up to you. Usually, those workflow flights look like that you I usually have one job where I just do everything at once. If you want to get a little bit fancy doing things in parallel, you can, certainly do that. And what you need for every of those builds or pipeline steps is that you define where it should be run on. There are certain options there. In order to have Chrome available on the latest version, which we want to have because we are not interested. When we run Chrome on Linux, we will get a version that is 3-4 years old, which doesn't represent our users anymore. So that's why for GitHub Actions, at least, I recommend to run on latest macOS, right? Which, these days it doesn't matter, which I don't think there's a difference these days anymore if a browser runs on on Mac or on Windows. Essentially the same will happen. And then you redefine the steps for this pipeline. So first, we check out, every pipeline step can have a name. So this is optional, but you can say, okay, we first start our checkout that uses a certain action. And that's one of the nice things about GitHub Actions is that it has, similar to WebdriverIO, like a large ecosystem of actions that you can just pull in to do certain things very easily. So instead of installing Git, instead of passing in my Git URL and all this stuff, I can just use this GitHub action, and I don't even need to give it any parameters. It knows that it should fetch the repository where this YAML file is defined in. You can, of course, fetch every random repository, but in this case, we usually want to test the files that are located in this repository. So next, we want to run our tests already, or let's say we start with the setup step. This setup step, it will run a bunch of shell commands. In this case, we will go to, let's say, our I think so. Our previous solution, I think that's the easiest. Yeah. So when we have checked the repository out, we are located in the root of the repository. So we can just go ahead and say, okay, we change the directory to go into. In this case, it can be wherever. If you have all your files in your local, like on the root directory, you don't need this step. But for me, the files in this case are in solution/chapter _8. So that's the first step. The second is I install all my dependencies for that, because I have installed my dependency locally, but on CI/CD, those have to be installed every time. And if you want to speed up this step, you can work with cache, which also with a cache that also is provided by GitHub Actions. The next step is test our run our WebdriverIO pipeline or WebdriverIO command, which is essentially saying, okay, run npx, which is a shorthand to access the binary that is the Wdidio binary that is installed locally. So access Wdidio and run the test, which I think we have defined. Let me just check in the solutions as an npm step in my package.json. Yep. So we have a default package.json. So what we can also do is just say npx Wdio or npx Wdio run the config file, whatever you prefer. And that's it. That's all we need to do to configure our pipeline step. So let me check this in. So what I will do is just push the YAML file that I just created and say workshop live coding, and then I push it upstream. And so what will happen is in the Actions tab, we now see 3 jobs because I have already 3 files. Let me switch to the browser. So you see 3 jobs for my commit that I called workshop live coding. And so I already had 2 YAML files, and this is the one I created. So we can go in there. And you see our pipeline step that we call test. And we can now watch the pipeline to be run. So it checks out everything. Interestingly enough, it fails, which is great because no pipeline is supposed to pass. Okay, something is wrong here. Let's switch back to the IDE and fix this. So let's see, was this the right path? I think the CD was wrong. Yep, it is solutions and not solution. That's great. Back to, well, let me do a quick commit this change. And second test. Switching back to the browser. And hopefully we get another 3 tests being triggered and going into this one. Sets up the job, it fetches our repository, it now installs our dependencies, which will go probably much quicker than on my local machine. And then we'll trigger the test, and given that we have, it will install Chrome driver, and the Chrome driver will use, I think chapter 8 uses Chrome driver, but it will use either Selenium standalone service or the Chrome driver service, whatever you have set up, and it is able to run Chrome in this VM on a Mac with Chrome driver. So it should essentially be the same as running this locally. It takes some time to install the dependencies. It takes some time, definitely. Well, in the meantime, we can check what else. And workshop. We might can do another one. I think, I'm not sure. Let's see. Yeah, I can show you in the meantime how. Yeah, we can work on the second task that we have in the workshop on chapter 8, CI/CD integration, which is bundle your Allure results page as a workflow artifact. So that means to store our Allure results and our HTML files to be able to download that one, and in case our test breaks. So let's go back into the IDE, into our little workflow, and then we enhance that workflow by adding an additional step, which is, again, we are making use of one of those, okay, we name our step upload artifacts, and we make, again, use of a GitHub Actions that is provided by the community. Essentially, actually, in this case, it is provided by GitHub, which has built a bunch of those usable components. So this one is called actions/upload minus artifacts. You will find a catalog of all the possible GitHub actions available on the marketplace. I think they have an own marketplace, and all these components are free. If you see this GitHub action being prefixed by actions, then you know this is one developed by GitHub themselves. And so this one takes some parameters. In this case, we give this this artifact a name. We call it Allure Report, and the path to our Allure report is going to be the directory where we store that report. And in this case, it's given that one of the chapter meant to rename this report. It's a little bit different. My Allure report. That's it. That's all we need to add this additional step to our pipeline to upload the results. Let's check back. If we finally, yeah, it finally set up, and now it runs the WebdriverIO test. It takes a while. But in the meantime, we can already push up our change and see commit and store artifacts. And we push this up. Interesting. Second test already passed for this one. Well, before waiting on this, there's another pipeline to finish. We can just check into how this we're going to look like. This is 9. I think we need 8. So we look into the X1 where it already works. So now you see here we have an Allure result, Allure report, and this will make Chrome. You cannot see this right now, but this will make Chrome to download the Allure report as a zip, and you can now unzip it and look into the files to see what's going on. You can do this with any kind of reporter if you have, any sorts of files. There are GitHub actions that allow you to upload things to an AWS bucket or to any kind of like a storage. Okay, this is still filling for some reason. Interesting. That usually should exist. But yeah, that's about the CI/CD integration. I wish I could go over more CI/CD providers. Oh, I have this. This is the wrong name, no? Actions, upload artifacts. There's spelling in there. I'm pretty sure. Oh yeah, it's not supposed to be artifacts. It's supposed to be artifact. So yeah, that's the spelling, and it will tell you that. So let's just do a quick fix here in the browser. Go into the file and edit it. And then start commit, fix workflow. And this will trigger another pipeline that now finally, hopefully, will pass. Awesome. So with that, we got pretty far with all our chapters. We went to chapter 6 and finished chapter 8. I think there's a lot more that you can discover, from page objects to building up your WebdriverIO framework to provide a lot of coverage and provide a lot of features. And if you go through this after the workshop again, feel free, if you struggle somewhere, to file an issue, to reach out on the Gitter support channel. For the sake of time, because we have only 12 minutes left, I don't think it might make sense to go into another chapter because they all take their time. But again, feel free to revisit these chapters. If you struggle somewhere, file an issue. And I'm happy to go into questions. Thank you, everyone, for sticking around. I think that was my longest workshop that I've given so far, online at least. So really happy that everyone was sticking around to the end. So yeah, if you have any questions, please let me and Enrique know. We're here. If you still struggle with the task, please send us a chat message, or unmute yourself, or open your video.
Yeah. Hey, Christian, this is John again. So I actually wanted to know, I noticed in the documentation that the GA unit reporter is what is mentioned specifically with the Jenkins integration. I was wondering if you know that any other reporters are if any of the reporters are usable with a WDIO Jenkins integration.
Are you, with the WDIO Jenkins integration, are you referring to a specific service or reporter?
Yeah, well, I think some of our services we use Awesome.
Okay.
Now, also, I would wonder if Allure would potentially also be able to be pushed into Jenkins as well, or would there be a specific service that would have to be made for that?
Yeah, so the Allure Reporter, as I mentioned, where is it? So the Allure Reporter has a Jenkins integration. Let me switch back to my dual screen. Jenkins Allure Reporter integration. I used that one when we used Allure Reporter at Sauce.
Mm-hmm.
We had a WebdriverIO Allure integration, and essentially next to your jobs, it will have a link to the generated Allure report. So it just picks up the Allure results automatically. I'm trying to find. Yeah, if you Google for it, you will find it. Ah, yeah, right here. So for every of your build history, you see this little icon.
Mm-hmm.
That essentially is a link to the Allure report, the HTML files, that is then generated and hosted by Jenkins. So that worked pretty nicely, and yeah, that was great. That helped out, and I can send you this link if you want to.
Yeah, if you could link it into the chat, that'd be great. Thank you.
Yeah, because I believe you do need to install the Allure plugin in Jenkins itself, right? So that it serves the Allure report correctly.
Correct, and to be able to, for Jenkins to be able to render the HTML file and be the static server for the HTML file, you need to loosen up some some settings. There's some specific settings you need to set into Jenkins. I think it's this one that will pretty much tell Jenkins, hey, please allow me to serve the HTML files. But it should be explained in here. Maybe it has already changed. I haven't used Jenkins for a while yet, but it was pretty nice integration. Well, I hope you all have enjoyed the workshop, and I'm not sure if there will be a recording of this. I could have recorded it actually myself, but that would probably even more kill my CPU. But in case you're interested, I think there is on the Webdriver documentation page under Add Community. We have under Resources, under Materials, we have the workshop. And I did this workshop at the OpenJS World. So if we Google on YouTube the nuts and bolts of WebdriverIO, OpenJS World, then you will find this workshop. And essentially the same what it's not that long. I think it's just 1 hour 50, but it goes through some of these chapters again. And maybe I'm gonna at some point stream this again when I get the chance to have this workshop online. I will record this and put it online, and maybe it was recorded, who knows.
So I'm sorry, Christian, those videos that you just had on your screen, are those available at a certain publicly available website?
Yeah, so it's on YouTube.
It's on YouTube?
So,
okay.
Yeah, this is YouTube in dark mode. Just Google the title of this workshop and you should find it. Again, I think I've done essentially the same format, went through the same steps with the to-do application. And I think this one is finishing even the Sauce Apps integration. This one is finishing almost all chapters. So you can take a look to see how other chapters were covered. And again, I will share again the link to this workshop. It's on GitHub. And you can also, if you go on the Webdriver docs page, under community and materials, you have access to it as well. And under resources, you find a list of books, video courses, conference and meetup talks, as well as webinars that you can watch and access for free. So make sure to check that out. With that said, yeah, thank you so much, everyone, for sticking around to the end. It was a pleasure. And yeah, I hope you enjoyed, and hopefully see you all soon.